Yes. Hey, hey. Welcome back. My God, I told I'll not tell hey, hey, but hey, hey is ingrained in me. So let's hey, hey again. And let's solve 2583, which is Kth Largest Sum in a binary tree. And man, it has been very long since I did some DSA, and I thought, why not restart DSA? And what is not better than a tree question? Tree always brings me joy. So let's do a tree question. So this is a straightforward question, I feel. So you are given a root of a binary tree and a positive integer key. And the level sum is the sum of the values of all the nodes which are on the same level. And as soon as you see this, only one thing should pop into your mind. If you remember long ago, it's always done level order traversal, level order traversal, level order traversal. Yeah, I told tell three times. So this is a straightforward implementation of level order traversal. So yeah, just calculate the sum of each level. So 8 plus 9, 17. First level is 5. Don't forget level 1. And then 2, 1, 1, 3, 7. 13, 4, 6, 10. And the second largest sum, and they are given k equal to second largest sum is 13. They are not given an example for like negative index, so let's try 9. Because we had to put 9 only, we can't put 10 over here because it will turn the n has to be from 0 to 9, mainly because n is the number of nodes and k will always be between 1 to n. So since we have 9 nodes over here, we have to put 9 only. And it is pretty obvious from the diagram that this tree doesn't have 9 nodes. So the result of this should be minus 1. Okay, that's written minus 1. Yeah, let's go. It got fast. Let's submit it. No, wait, you think you can do that? Just have one single case. And yeah, so things that does not have 9 nodes, we'll do minus 1. So as soon as you see this, there is only one thing you should come to your mind, and that is the loader reversal. There is an implement. We had the loader reversal for this, so let's do that. You should be able to write this with your eyes closed. Yeah, you'll have the root over there. And while you use this, what you'll do? For underscore in range the length of q, you take the okay, take the node which is nothing but q dot pop left. And what to do? If the node dot left exists, then the node dot left, and yeah, let's do the same for right also. Just find a way to always reduce your workload. So here, if you see, then we can do like this, we can do like this, we can do like this, and put left, and that made me type less. So we'll do that for right also. Yeah, this is the straightforward implementation of level order traversal. So what we'll do, since we have to calculate each sum, we'll have a variable of sum which is 0, and for each node what we'll do, this is equal to node dot data. It's value over here. Yeah. Let's print the value over here after the for loop. Don't print it before the for loop. Also tab. Hey, hey, hey. Shift tab. Yeah. Oh my god, what happened? Shift tab. Yeah. I'm calling it yes over there. I'm typing value over here. What has happened to me? And let's see for case one. So yeah, you got the values of this 5, 7, 13, and 10. So let's do it the naive way. So we'll have it in an array. And what we'll do? So for array, to array, we will append the value of yes. So what will happen now? Okay, let's make it minus 10 to see the first test case only. Let's make it a bit big. And let's print ARR also. Yeah, 5 times 5, 17, 13, 10. That is what is expected. And you have to return the second highest value. So what we'll do? For that we'll sort the array. So let's print the sorted array. And as you see, you got 5, 10, 13, 17. And you have to return sorted array to the position k. Will give you the kth biggest element. So your kth smallest element. So if you print this, you will get 10, but you want 13. What happens? This is sort of thing. Test case. Okay. Okay, for case, which case is there? Okay, yeah. Let's handle that also. First, we'll have k is equal to 2. That is a very simple fix to do that. I'll show how to do that. Let's look up value. Yeah. So, your standard output is 13. Uh, so, let's just return this. Um, it should not be 13. I don't know why it's 13. That is because it is 0 index. That's why it's 13. Yeah, obviously it will fail. Because you have to return minus k. It should not return the kth element. It should return the kth element from the end, which is nothing but minus k. Yeah, it won't. Let's submit it one. Oh no, if you submit, you will all the textbooks will not pass. So what you have to do before doing this, you have to check if the length of array is less than k, then what you have to do, you have to return the value of minus one. Let's use this test case. I forgot to add a gal clause because that is the thing. If by any chance our length of our array is less than k, that means that the array was very small, so the number of nodes were higher than the level itself. Yeah, as it returns, and I don't know how it's running in 92% speed because we are actually sorting the array also. And yeah, that was the most naive way to do it, but let's do it the optimal way. So rather than an array, what comes to your mind when you think of sorted item? It should be a heap. So let's make it a heap. Yeah, it's already a heap only, like declaration is correct. So rather than appending to the array, what we will do? So you will append it to the heap. So, so to the heap or the array, you want to push the value of s. After you push, if by any chance the length of your heap becomes greater than k, what you will do? That means you you have a very big element which is exceeding your entire heap itself. Like how can I tell more than exceeding your entire heap? So what is happening is the length of your heap has crossed the number of elements required to get the kth largest element. So it does not make sense to store any extra elements if you understand what I'm saying. So for example, if you have take this only, yeah, if you have k is equal to 2, if you have k is equal to 2, after first iteration, what will happen? Your heap will have 5, and then you will have 17, and then you will have 13, and then you will have 10. But and then yeah, after sorting it becomes like this. But does it make sense to have 5 and 10? Because that is guaranteed that these two will never be in the heap. So why keep them? So by any chance, if you find elements which are if you have elements greater than k, then better drop the smaller values. So what we'll do, since we are using a min heap over here, smaller values will always get off, and if the length of the heap becomes greater than k, then you want to pop out from the array itself. Yeah. And again, so you'll have the same check. If length of array is less than k, the return value is. But or if there's no need for to sort the array, you can directly do pop out the topmost element. Yeah, this should also work the same. It's EFT, not he off, it's he pop. Oh my god, it's not heap, it's array. Yeah, it's also run. This should be greater than 93, but it's less than 93, then I'll. Oh my god, see, this is why you should never write optimal codes. It's 58%. Let's just submit it again. Let's go 15%. Just God knows how much more inefficient than creating an array, sorting the array, and hey, don't ask questions. Just yeah, that's all for it. Thank you for watching and goodbye.